Hello, Sunny Slope. So this is Mr. Daniel back again with another YouTube video. So we're continuing with our theme of steam. Today we're actually going to do another science experiment, but specifically with in regards to ice cubes and water. So we're going to actually need four cups, and we're going to need ice, and we're going to need salt, and we're going to cut 4 pieces of yarn into 20 centimeters long. So what we're trying to show is that ultimately, salt has an effect on ice, right? So ice is the solid form of water. So when water is cooled to really low temperatures, right, the molecules that are normally very moving and flowing, right? So there's a lot of space in between them when it's a liquid, start getting closer and closer together when the temperature starts dropping, and they become a solid. And so that's where they become ice. So we're going to try to show, we're going to try to actually see if there's a difference when we add salt to 2 of our cups versus adding no salt to the other 2 cups, and trying to see if the yarn will stick to the ice cubes, and then we would be able to lift them up. So ultimately, we're going to try to see if we can figure this out. I'll explain a little bit further after we see what happens with the experiment. So all right, let's get to it. All right, see you soon. Bye. Alright, y'all. So for our next video, we have 4 cups filled with ice. Okay, we have string. And so we're placing this yarn string next to the ice. We're going to see if the ice will attach to or kind of connect to the string, if the yarn will be able to pull up the ice or get stuck to the ice. So on 2 of them, we're actually going to put salt. And so what this is going to show, hopefully, is how salt helps to defrost. So lower the freezing temperature. So hopefully that will not allow the ice to freeze over. So they do this in essence what it is the trick is that salt put onto ice will regulate the freezing temperature and not allow it to get colder, right? And thus to solidify, and in essence it would be harder for it to form, and thus in certain areas they use it so that it doesn't form, and that way it would be easier for daily life. We'll explain a little bit further later, but the idea is we're going to leave this here for about 3 minutes. Once it's done, we're going to try and see if the yarn gets stuck in the ones where we put salt, or and what happens when the other cups where we didn't put salt in. So see you guys in a bit. Okay, yo. So we have allowed for 3 minutes to pass. And we're gonna see. Hopefully, we did this correctly, and the yarn will attach to the ice in some of them, and it will not in the others. So we shall see. So first, we'll go with this one. So it looks like it could have potentially have gotten stuck, but it didn't. So this one looks a little bit more melted too, by the way. So let's look at the other one that we didn't put salt in. And yeah, no, just it does not. Yeah, it does not get stuck. So let's see one of the ones that we put salt in it. Let's see. Yo, and there it is. So the yarn is able to pick up the ice. Let's try with this other one. Look at that. Oh, it did have it. Okay. So, regardless, we have one. when we put it in the water, it stopped the effect. But anyways, we did see that the yarn was able to pick up the ice after having put salt in these two. So we put salt in these two because what it does is it depresses the freezing point. So what that means is that it makes it harder to get to the freezing point, right? So, in essence, you would keep the ice in a state of not forming more. Actually, is that even... All right, Sunny Soap kids. So we had the experiment with the water and the ice cubes, and the two that did not have salt and the other two that did have salt. So what we just witnessed is that in regards to the yarn with the pure water and ice cubes, the ice cubes were not able to freeze the yarn onto the together. So the yarn just got wet, in essence. And with the ones where we had salt, it caused a little bit of melting, and ultimately the science of it is that because of the small melting, the yarn was able to sit closer to the cold aspects of the ice, right? The colder, more solid aspects of the core of the ice cube, and it froze it together, and we were able to pick it up. Now, a key important thing about this is that salt is actually an element which makes it harder for water to freeze. So a lot of times in places where there's a lot of snow and there's a lot of ice, they add salt to the roads in order so that ice doesn't form on the road and become solid, because then ultimately that'd be a driving hazard, and your wheels because remember, ice is pretty sharp. You could end up puncturing a tire, or your tires could skid and your vehicle could crash. So ultimately, salt is necessary in these roads, in these places where it's really cold, in order to make sure that ice isn't formed. Now, there's other places where that might not be enough, and they have to actually get these snow plows and plow ice off of the roads, and then add some salt in order to help to make sure that the ice doesn't form from when it's snowing. Okay, so hope you guys understood that. I know it's a handful, but the idea is that what we have to know is that salt affects our freezing point for water, right? So it makes it harder for the ice to actually form, right? For water to turn into a solid, right? Versus when it's the case for natural water, the ice melts a lot. The water becomes colder faster because of the fact that there isn't the salt element, right? So the salt in this case, it was still able to melt a little bit of the ice cube, but in essence, it still it actually made it so that the ice so that the water would stay cool and wouldn't turn into a solid. Hope you all enjoyed the video, kids. Hope you all enjoyed the video. We miss you. We hope you all are seeing our YouTube videos, and remember that there's a lot of information there. We still have our tutoring, so we'll still be checking in, and hope to hear from you all soon. All right, kids. Bye.